in minus pi to pi. What is this function? Is an even function. Is an even function. I already told you. Therefore, the quotient bn equal to what? 0. This is true for all n. Then Fourier series is what it becomes. F of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx. An cos nx. This is Fourier series of an even function. For even function, clearly the quotient bn is 0. For odd function, a naught 0, an 0. Only bn is not 0. Now coming to a naught. What is the formula of a naught? In the first interval minus pi to pi, 1 by pi, integral minus pi to pi f of x dx. Right? Since it is even function, I can write this as 2 into 0 to pi. So even function means limits can be taken as 2 into 0 to pi f of x dx. Right? And what is the function now? 2 by pi. 2 by pi integral 0 to pi. The function is what? Mod cosine x dx. Mod cosine x dx. And the main important point is, now just listen. One can think, since it is modulus, one can write immediately. Since it is modulus, one can write cos dx, cos x dx. And what is this? Is 2 by pi. This is integral sine x between 0 to pi. So 2 by pi sine pi 0, sine 0 0. So entirely 0. A naught value 0. Similarly, if you take this mod cosine x as cos x, an will be also 0. So there is a wrong procedure here. What is that? We have to consider the behavior of the mod cosine x in the interval 0 to pi. In the interval 0 to pi. That means here you write this is 0 and this is pi. And in the first quadrant, mod cos x is definitely positive. This is pi by 2. But in the second quadrant, what is mod cos x is minus cosine x. Minus cosine x. Therefore, I have to split the 0 to pi into two parts. That is equal to 2 by pi, this bracket open, 0 to pi by 2 is one part. In 0 to pi by 2, what is mod cos x? Cosine x plus. And pi by 2 to pi, this mod cos x is what? Minus cosine x dx. Minus cosine x dx. This is the logic in this problem. Okay. And remaining everything same. So let me evaluate this. This is sine x between 0 to pi by 2 minus, this is also sine x between, but limits are changed, pi by 2 to pi. That is equal to 2 by pi, this is upper limit, sine pi by 2 1, sine 0 0 minus upper limit sine pi 0, sine pi by 2 1. So this is 1 plus 1 2. It's totally 4 by pi. 4 by pi. So a naught value is what? 4 over pi. A naught value is over. Now coming to an. An formula 1 by pi minus pi to pi f of x into cos nx dx. F of x into cos nx dx. So I can, since this is even function, cosine is also even function. So I can write the limits as 2 into 0 to pi f of x into cos nx dx. F of x into cos nx dx. This implies an is equal to 2 by pi. Now since the function is behavior is in different way in two intervals, 0 to pi by 2, f of x is, okay, let me write one more step. 2 by pi integral 0 to pi, this is mod cosine x into cos nx dx. Cos nx dx. That is equal to 2 by pi, this is 0 to pi by 2. Mod cosine x is positive. So cos x into cos nx dx plus integral pi by 2 to pi, and mod cosine x is what? Minus cosine x into cos nx dx. Cos nx dx. Okay. Now evaluate this. Anybody tell me fast? What is the answer? Cos nx dx. Now this is cos a cos b. cos A cos B formula. So take these two inside. This is 1 over pi. This is integral 0 to pi by 2. Taking 2 inside, cos A cos B formula, 2 cos A, 2 cos A cos B, 2 cos A cos B formula, cos A plus B. That means 1 plus nx plus cos A minus B. 1 minus nx. This is dx. And plus, okay, this is minus is there. So minus integral pi by 2 to pi, integral pi by 2 to pi. This is also 2 cos A cos B. So cos A plus B plus cos A minus B. Cos A minus B. And this whole bracket closed. Okay, only the same integration, but limits are changed. One interval is, one limits are 0 to 2 by 2, other limits are pi by 2 to pi. So let me evaluate now. This is equal to 1 by pi. First, cosine integration, sine 1 plus nx by 1 plus n. And this is also sine 1 minus nx by 1 minus n. These are between what limits? 0 to pi by 2. First thing is over. Minus. Same integration. There is no change in the integration, but limits are changed. 1 plus n plus sine 1 minus nx by 1 minus n between what limits? Pi by 2 to pi. Pi by 2 to pi. Okay. Now this is equal to 1 by pi. First one, upper limit, pi by 2. Sine, this is in place of x, pi by 2, and take that pi by 2 inside, multiplied by 1 plus. This is pi by 2 plus n pi by 2 by 1 plus n plus sine pi by 2 minus n pi by 2 by 1 minus n. This is upper limit. This is upper limit. Minus, coming to lower limit, 0 in place of x. Sine 0, 0. So 0 plus 0. So first bracket limits are over. Coming to second one, minus. Minus is there and I have to substitute upper and lower. So for this I am one bracket. Upper limit is what? Pi. Sine n pi 0. Sine n pi 0. So sine n pi 0. This is also 0. Upper limit 0. Minus, coming to lower limit, pi by 2. Sine pi by 2 plus n pi by 1 plus n plus sine pi by 2 minus n pi by 1 minus n. This bracket closed and a whole bracket closed. Remember, this bracket is for second limits. Now, what is sine pi by 2 plus theta? Cos theta. So this is equal to 1 by pi. This is cos n pi by 2 by 1 plus n. Sine pi by 2 minus theta also same. Cos n pi by 2 by 1 minus n. This is 0, this is 0, and this minus into minus plus same expression. Cos n pi by 2 by 1 plus n plus cos n pi by 2. Sorry. This is n pi by 2. This is n pi by 2. N pi by 2 by 1 minus n. Now, all are same. What is the common? Cos n pi by 2 is common. So outside, cos n pi by 2 by pi. And what is this? 2 by 1 plus n plus 2 by 1 minus n. Okay, that is equal to 2 also common. 2 cos n pi by 2 by pi. This is LCM 1 minus n plus 1 plus n by, this is 1 minus n square. 1 minus n square. Okay. Now this is equal to n gets cancelled 2. So 4 cos n pi over 2 by 1 minus n square into pi. So I can write an as 4 into cos n pi by 2. 4 into cos n pi by 2 minus, I will take pi into n square minus 1. Pi into n square minus 1. Or one can write this is minus 4 cos n pi by 2 by pi into n minus 1 into n plus 1. N minus 1 into n plus 1. And remember, let me write this one. An is equal to minus 4 cos n pi by 2 by pi into n square minus 1. This is uh, the value of an. This is for n not equal to 1, because here denominator n equal to 1, it goes to infinity. N equal to 1 is applicable in Fourier series. A1 quotient will be there. So this a n equal to 1. Okay. So now for n equal to 1, again begin with formula. Now for n equal to 1, what is an formula? 1 by pi minus pi to pi f of x into cos nx dx. F of x into cos nx dx. This implies what is a1 becomes, I will write directly since it is an even function, 2 by pi integral 0 to pi. This is mod cosine x into cos x dx. Cos x dx. This is for n equal to 1. Substitute n equal to 1. Okay. Now again same procedure as per the behavior of the mod cosine x. Split the interval into two parts, 0 to pi by 2. This is plus cos x into cos x dx, plus over pi by 2 to pi, the mod cosine x value is minus cosine x into cos x dx. Into cos x dx. Okay. Now integration part. This is 2 by pi cos square x. Okay, let me write one more step. Cos square x can be taken as 1 plus cos 2x. Do you remember reduction formula in intermediate? Anyone? I will tell, because that's better. This is what? This is cos square x dx and minus pi by 2 to pi. Pi by 2 to pi. And this is also cos square x dx. I will write the second term cos square x as 1 plus cos 2x by 2. 1 plus cos 2x by 2. Why I am not writing the first term? Because in intermediate, the reduction formula, I will tell very in a simple manner. Reduction formula, what is that? The limits must be 0 to pi by 2. The limits must be 0 to pi by 2. Not pi by 2 to pi or anything, only 0 to pi by 2. This is cos to the power of nx dx, or cos to the power of nx dx, or sine to the power of nx dx, or product sine power mx, sine power m into x, cos power n into x. All those formula, the logic is what? This first decrease 1 unit in this power, that is n minus 1. It is a fraction. First decrease 1 unit in exponent n minus 1, then reduce to 2 units, that is n minus 3, n minus 5, and so on and so on, and write the exponent as it is, n, then again reduce to 2 units, n minus 2, n minus 4, and so on. Okay, this is the answer. Another one is what? This is what? And if I write this formula, that is first in the numerator reduce 1 unit in the exponent, then 2 units in the numerator, and at last if you get 1, and in denominator write first exponent n, then reduce to 2 units, that is n minus 2, n minus 4, and last you will get 2. If it is lastly 1 by 2, then it is multiplied by pi by 2. It is multiplied by pi by 2. This is the reduction formula. Let me apply this. This is 0 to pi by 2. Yes, limits are there. Cos power cos square x. So what is this becomes? This is equal to, this is a1 equal to 2 by pi. For the first one, what is the power in place of 2? n2 is there, so decrease 1 unit. That's it. No reduction of 2. Don't take negative values or zeros, and write the exponent 2 and decrease 2 units. This becomes 0, so don't write. Lastly, we are getting what? 1 by 2. When it is 1 by 2 multiplied by pi by 2. And for the second integral, it is not applicable. By why? Because the limits are not 0 to pi by 2. Okay. Now, this is equal to, this is what? 1 by 2 into pi by 2. And next one, what is this sign? Minus 1 by 2 outside. This is x cos 2x integration sine 2x by 2. This is between pi by 2 to pi. This is between pi by 2 to pi. Okay. Now this is equal to 2 by pi. This is pi by 4 minus 1 by 2. First upper limit, this is pi, sine 2 pi 0, minus lower limit pi by 2, plus if I put pi by 2 in place of x, you will get pi, sine pi 0. So this is okay, right? So this is equal to 2 by pi by 4. This is pi minus pi by 2, pi by 2, pi by 2 into this one, pi by 2 into pi by, this is pi by 4, I think, isn't it? Any corrections, anybody? Cos square x, this is right. This is 1 by 2x, sine 2x by 2 is correct. This is pi and sine pi 0, correct. This is pi by 2 and this is also right. And this is minus, this is pi minus pi by 2, pi by 2. Pi by 2 into 1 by 2, pi by 4. Yeah, pi by 4 minus pi by 4, 0. So a1 value is 0. A1 value is 0. Now, after calculating, therefore, the Fourier series is, what is f of x equal to, what is a0 value? Where it is? Yeah, a0 value 4 by pi. A0 value 4 by pi. So 4 by pi into a0 by 2 plus summation n equal to 1 to infinity. And what is an value? What is an value? Minus 4 cos n pi by 2 minus 4
n equal to 2 to infinity.
Cos n pi by 2. Yeah, 2 to infinity. Exactly. Very good. 2 to infinity pi into n square minus 1 into cos nx. That is equal to 2 by pi minus 4 by pi summation n equal to 2 to infinity cos n pi by 2 by n square minus 1 into cos nx dx. Cos nx. This is the Fourier series of mod cos x. Mod cos x. Any doubts?
Sir, for this case, it's not needed to take bn, sir.
No, why? Because it is even function, no? Mod, always mod function is what? Always even function. For even function, what is bn? Bn quotient is 1 by pi, listen, minus pi to pi, f of x into sine nx dx, right?
Yes, sir.
What is f of x here? Even function. This is even function, and this sine is what function? Odd function, no?
Yes, sir.
So in this total f of x into sine nx, this is my function, entire function. If I replace x by minus x, since this is even function, this becomes this, and sine nx becomes what? Minus sine nx, right? When I replace x by minus x.
Yes, sir.
So this is odd function, f of x into sine nx. Integration between the limits minus pi to pi, odd function is definitely what? 0.
0.
Yeah, that's why.
Thank you.
Remember, no need to calculate always. In minus pi to pi, decide whether the function is even or odd. If it is even, bn 0. If it is odd, a0 0, an 0. Bn will be there.
Thank you, sir.
And there are some problems, actually previous problems. In minus pi to pi, the function is neither even nor odd. Then apply entire procedure. You calculate a0, an and bn. Okay?
Okay, sir. Thank you, sir.
Right. Next one. Take this as assignment. F of x equal to mod sin x. Mod sin x in minus pi to pi. Okay. Now, let me tell another problem. Catch this logic. Find the Fourier series. Find the Fourier series of, see this function f of x equal to 1 plus 2x by pi in the interval minus pi less than or equal to x less than or equal to 0 equal to 1 minus 2x by pi 0 less than or equal to x less than or equal to pi, and deduce that 1 by 1 square plus 1 by 3 square 1 by 5 square and so on is equal to pi square by 8. Pi square by 8. Now, the function is given as f of x equal to, it is defined in two intervals, 1 plus 2x by pi in the interval, first interval, 1 minus 2x by pi in the second interval, right? You can proceed in as usual manner. What is the interval? Entire interval is what? Minus pi to pi. Entire interval is what? Minus pi to pi. Now, is it possible to check whether this function is even or odd? Let me check. First thing. In the first interval, if I replace x by minus x, in the first interval, x by minus x, what is this? Let me write. In minus pi less than or equal to x less than or equal to 0, f of minus x, then what is this? Becomes 1 plus 2 into minus x by pi. What is this value now? 1 minus 2x by pi. What is 1 minus 2x by pi? It is also what? It is also f of x, but in what interval? 0 to pi. 0 less than or equal to x less than or equal to pi. Doesn't matter. F of minus x is what? F of x now. Now another interval. Let me consider in 0 less than or equal to x less than or equal to pi. Now in this function replace x by minus x. Actually, what is the function? This is, and replace x by minus x. Then it becomes 1 plus 2x by pi, which is f of x in what interval? In minus pi to 0 interval. In minus pi to 0 interval. So f of minus x equal to f of x. Therefore, f of x is an even function. F of x is an even function in minus pi to pi. Always remember, don't check in 0 to pi. Even and odd function concept is only in minus pi to pi. Since it is even function is over. Therefore, even function means what? Therefore, which quotient is 0? Bn is 0. Therefore, what is the Fourier series is f of x equal to a naught by 2 plus summation an cos nx. This is equation 1 to infinity. Now, where a naught equal to 1 by pi minus pi to pi f of x dx. Now here the main point is, since function is even function, I can write this as 0 to pi f of x dx. And in 0 to pi, see what are the limits now? 0 pi. In 0 to pi, what is the function value use? No need to consider in minus pi to 0 value. This is 1 minus 2x by pi. This is the logic in this problem. Okay, interval, according to the interval 0 to pi, we consider that function only, 1 minus 2x by pi. So that is equal to 2 by pi, this is x, minus 2 by pi into x square by 2 between 0 to pi. This is equal to 2 gets cancelled. 2 by pi, upper limit, this is pi minus pi square by pi. This is upper limit minus lower limit. What is the lower limit? Is it correct? This is x square by 2 gets cancelled, right? Done. And this is the lower limit, since x terms are there, zeros. Okay, so this is pi square, this is completely 0. This implies what is a naught value? 0. What is a naught value? 0. Next one, an. Next, now an equal to 1 by pi minus pi to pi f of x into cos nx dx. Since it is even function, I can write 2 into 0 to pi f of x into cos nx dx. And in the interval 0 to pi, what is f of x value? 2 by pi, 0 to pi, the value is 1 minus 2x by pi. 1 minus 2x by pi cosine nx dx. Cosine nx dx. Now, by parts formula, repeated by parts formula, derivative part, this is derivative part and this is integrating part. So this is 2 by pi. First, derivative part as it is, 1 minus 2x by pi as it is, cosine nx integration sine nx by n minus. Now this derivative part derivative, what is that? 1 derivative 0, x derivative 1, so I will get minus 2 by pi, and sine integration minus cos nx by n square. Right, again 2 by pi derivative 0, so stop here. 0 to pi, 0 to pi. Now This is equal to by pi. Now substitution of limits. Upper limit, if I substitute here, sin in pi, 0 into something 0, minus minus minus, so minus 2 by pi n square cos n pi. This will be there. Now coming to lower limit, 0, sin 0 0, so entire 0 first term, and minus 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 minus, yeah, just wait. This is pi, this is 0, and this is correct, minus, yeah, lower limit also, this is minus, cos 0 value 1, so 2 by pi n square. This is equal to 2 by pi, this is minus into minus plus, this is minus, so 2 by pi n square common, so this term will be first 1 minus cos n pi. So this is 4 by why pi is here? Yeah, it is pi is here, that is fine, right? Next one, 4 by pi square n square 1 minus minus 1 whole power n. Cos n pi value minus 1 whole power n. Therefore, what is the expression for an? Expression for an, it is 0 if n is even, isn't it? When n is even, this is plus 1, 1 minus 1, 0. When n is odd, this is minus 1 plus 2, so it becomes 8 by pi square n square if n is odd.
0 plus no, sir.
Yes, any mistake?
0 plus 2 by pi n square no, sir.
I'm not getting you. Voice is not clear.
0 plus 2 by pi n square no, sir.
0 plus?
2 by pi n square.
Where?
Top, sir.
This statement?
Yes, sir.
This is minus into minus plus, right? 2 by pi n square I have taken common. So I am writing this term first, 1. And 2 by pi n square common, minus cos n pi.
Okay, sir.
Right now? Okay. Now, therefore, what is the Fourier series? Therefore, Fourier series is f of x equal to a naught value 0 plus an is defined for what values? Odd values. Or one can write how? 1, comma 3, comma 5, up dash up to infinity. What is the value? 8 by pi square n square cos nx. If I expand this, f of x equal to 8 by pi square outside, which is not 8 by pi square is the constant outside the summation. Now if I substitute n value, this is cos x by 1 square, odd values only, cos 3x by 3 square, cos 5x by 5 square, and so on. Done? Okay, this is Fourier series is over. This is the required Fourier series, and for the deduction, that series expansion, what to get series expansion, put x equal to 0. Put x equal to 0. This is f of 0 equal to 8 by pi square, 1 by 1 square, 1 by 3 square, 1 by 5 square, and so on. And what is f of 0 value? See, what is the function is defined as? F of x equal to 1 plus 2x by pi in what interval? Minus pi less than or equal to 0. 1 minus 2x by pi, 0 less than or equal to. That means at x equal to 0, the function value is given. It is not defined. It is defined. At x equal to 0, what is the function value? Here, when I put x equal to 0, 1. In the second interval also, when I put x equal to 0, 1. So function is continuous everywhere. Okay. Clearly, f of 0 value is 1 minus 2x by pi or 1 plus 2x by pi. 1 minus 2x by pi at x equal to 0, or one can take 1 plus 2x by pi at x equal to 0. So both gives what value? 1. So it is continuous at 0. So this implies 1 equal to 8 by pi square, 1 by 1 square plus 1 by 3 square, and so on. That implies 1 by 1 square, 1 by 3 square, and so on is equal to pi square by 8. One can write this as another notation, 1 by 2n minus 1 whole square n equal to 1 to infinity is pi square by 8. Is pi square by 8. This is one model problem. Let me give some problems based on these methods. See, first one, assignment problems. Assignment problems. What is the first one? I have given f of x equal to modulus of sin x in minus pi to pi. Second one, f of x equal to find Fourier series. Okay, the question is f of x equal to 0, minus pi less than or equal to x less than or equal to 0, and the sin x in 0 less than or equal to x less than or equal to pi. Deduce that 1 by 1 into 3 minus 1 by 3 into 5 minus 1 by 5 into 7, this is plus, next minus, and so on, is equal to pi minus 2 by 4, pi minus 2 by 4. And next one, yeah, take this. Third, f of x equal to minus pi. I think I told this before. Right. Next one, this is solved already. Yeah, take this. F of x equal to x. F of x equal to x between 0 to pi, and 2 pi minus x. 2 pi minus x in pi to 2 pi. In pi to 2 pi. Okay. Deduce that 1 by 1 square, 1 by 3 square, 1 by 5 square. This value is pi square by 8. Standard notation. 0 to pi. That's easy. No problem. Yeah, take this. Fourth one. F of x equal to x square 0 less than or equal to x less than or equal to pi minus x square minus pi less than or equal to x less than or equal to 0. See this problem? Here the minus pi to 0 is given here and 0 to pi is given here. So what is the complete interval? Minus pi to pi. Okay. And next change of interval is there. Not this problem. 0 to pi. Yeah. Lastly, one more problem. Fifth one. An alternate series. An alternate current after passing through. An alternate current after passing through a rectifier. After passing through a rectifier. Electrical problem has the form I equal to capital I naught sine x in the interval 0 less than x less than or equal to pi, and 0 in the interval pi to 2 pi. In the interval pi to 2 pi, where I naught is the maximum current. I naught is the maximum current, and the period is 2 pi. Express I as Fourier series, and evaluate 1 by 1 into 3 plus 1 by 3 into 5 plus 1 by 5 into 7 and so on. Okay, this is a problem application of a Fourier series in electrical problems. These are the problems completely in the interval 0 to 2 pi and minus pi to pi. 0 to 2 pi and minus pi to pi. Now the main point, listen now. The Fourier series of f of x is defined in the interval of length, of length 2 pi. 2 pi, that is what, 0 to 2 pi, or what is the another interval, minus pi to pi. Okay, 0 to 2 pi or minus pi to pi. But in general, the Fourier series of f of x, is defined in the interval of length, 2L. See, all of you, remember, generally Fourier series is defined in the interval of length 2L. That is, this may be 0 to 2L or minus L to L. So what is a special case? This is the general case. That is, I have given general case. So when L equal to pi, the case, this first case, when L equal to pi, we have case 1. But till now we have the formula in interval 0 to 2 pi or minus pi to pi. Now, what is the Fourier series formula in 0 to 2L? L may be any positive real number. Maybe pi, maybe 2, maybe 1, like that. Any positive real number. Okay. Now, what is the formula? This is called arbitrary interval. So, now the point is, the Fourier series of f of x, in an arbitrary interval, of length 2L, that is, let me first consider 0 to 2 pi, 2L. The Fourier series of f of x in an arbitrary interval of length 2L, that is 0 to 2L, is f of x equal to, the first term, there is no change, a0 by 2, plus second one, n equal to 1 to infinity, an, previously what, in 0 to 2 pi cos nx, now this is n pi x by L. N pi, in place of n, what is the change? N pi by L will be there. And another term, this is n to bn sine n pi x by L. This is the Fourier series formula in an arbitrary interval where a0 value is 1 by L, this becomes 0 to 2L interval f of x dx. This is a0 formula. Okay. And an formula is 1 by L, 0 to 2L, f of x into cos nx previously. Now in place of nx, n pi x by L. And bn formula is 1 by L, 0 to 2L, f of x into sine nx previously. Now here, sine n pi x by L dx. This is the structure of Fourier series in an arbitrary interval. Okay. And what is the hint for this? Derivation is no need. Just hint is the variable. Again, you will confuse. No need. Just remember the formula. That's enough. Okay. Once again, in an arbitrary interval 0 to 2L, in place of nx, you will get n pi x by L. This is the observation. Just remember this. And not 1 by pi, 1 by L. When you substitute L equal to pi, again the same formula. See, when you substitute L equal to pi, pi gets cancelled. You will get cos nx here, sin nx here. Same logic here also. Okay. Now Fourier series. Fourier series in the interval. What is another one? In the interval of length 2L minus L to L is same formula, no change. a naught by 2 summation an cos n pi x by l, n pi x by l plus summation bn sine n pi x by l, and is from 1 to infinity, where same a naught is what, 1 by l, limits are just minus l to l, f of x dx. An is what, 1 by l minus l to l, f of x into cos n pi x by l dx. And next bn is what, 1 by l minus l to l, f of x into sine n pi x by l dx. Okay, and when minus l to l case is there, again concept 1. If f of x is even function in minus l to l, same logic, in minus l to l, then bn equal to 0. The same conditions, no change here, bn equal to 0. And second one, if f of x is an odd function, is an even function, or in minus l to l, then what are the quotients? A naught 0 and an 0, a naught 0 and an 0. Then you write, according to that, you write the Fourier series for even function and odd function. Even function and odd function. Is that clear? Now let me do one problem based on how much time left? 10 minutes. Okay. Find Fourier series of I think we did this problem, pi l into 2 more. That problem is better. It is there. No. Minus l to l, it is not there. So take this. F of x equal to pi x. Interval is 0 less than or equal to x less than or equal to 1. Pi into 2 minus x. 1 less than or equal to x less than or equal to 2. Deduce that sigma 1 by 2n minus 1 whole square 1 to infinity is pi square by 8. Is pi square by 8. Solution. What is the function is given as f of x equal to, first one is pi x in 0 to 1 interval and pi into 2 minus x in 1 to 2 interval. So what is the interval becomes completely 0 to 2. 0 to 2. Is that clear? 0 to 2. So what is the L value here? See, in this arbitrary interval, the most important point is identifying the value of L. Here the complete interval is 0 to 2. Compare this with the 0 to 2L. Always remember 0 to 2L. Therefore, what is 2L equal to 2? That implies L value 1. This is most important. L value 1. Now, therefore, Fourier series is, Fourier series of f of x is f of x equal to, the formula is same, a naught by 2 an cos n pi x by l 1 to infinity plus summation bn sine n pi x by l, and is 1 to infinity. Equation 1. At last I will substitute L value 1, and a naught formula is what, 1 by l, 0 to 2l is 0 to 2l f of x dx. And what is L value 1 and 0 to 2? The complete interval is what? Clearly it is called 0 to 2. Complete interval 0 to 2. So I have written to 0 to 2 f of x dx. But 0 to 2 is split into two parts. 0 to 1, what is the function value? Pi x. And in 1 to 2, the function value is pi into 2 minus x dx. Pi into 2 minus x dx. Therefore, this implies pi integration x square by 2 0 to 1 pi outside 2x minus x square by 2 1 to 2. This is pi upper limit 1 by 2 minus 0 plus pi, this is upper limit to 4 minus 4 by 2, and this is minus 2 minus 1 by 2, 2 minus 1 by 2. So this is pi by 2 plus pi into, this is 2 minus 3 by 2, isn't it? 4 minus 1, right, done. This is 4, 1 by 2. So pi by 2 plus pi by 2, this is pi. A naught value is pi. A naught value is pi. Now, an formula 1 by L, 0 to 2L, f of x into cos n pi x by L. That is equal to 1 by 1. This is 0 to 2. F of x, L value is what? 1. So you write cos n pi x. Cos n pi x. Now, it split the interval. In the first interval, the function is pi x into cos n pi x dx plus 1 to 2, 1 to 2, just wait, 1 to 2, this is pi into 2 minus x, cos n pi x dx. So, pi is constant outside. This x into cos n pi x, pi parts formula, derivative part x, cos n pi x derivative sin n pi x by n pi minus x derivative 1 sin integration cos n pi x by n pi into n pi, n square pi square. This is in between 0 to 1, first part, plus pi into the second interval. This is derivative and this is integrating 2 minus x. This is sin n pi x by n pi, okay, minus 2 derivative 1, 0, x derivative 1 minus 1, again integration of sin by n pi into n pi, n square pi square. This is between 1 to 2. Now, substitution of limits. First one, pi, upper limit 1, in place of x sin n pi 0, this is 0, and minus into minus plus, this is cos n pi by n square pi square. Upper limit is over, minus lower limit sin 0 0, minus into minus plus, cos 0 1, so remaining part 1 by n square pi square. First one is over, plus pi into, coming to second one, 2 is the upper limit, 2 minus 2 0, so this one 0, minus 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 plus cos, in place of x2, cos 2 n pi plus 1, so minus n square pi square, minus lower limit is 1, sin n pi will be there. If I put 1 here, sin n pi, so 0, minus 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 cos n pi, this becomes what? Cos n pi by n square pi square. This is closed. Now, so entirely pi common. This is plus with plus. This is also minus into minus plus. So 2 cos n pi by n square pi square. This is with minus, minus into plus minus, and this is also minus. So minus 2 n square pi square. So totally 2 pi by n square pi square is common, cos n pi minus 1, and this is equal to pi pi cancel, 2 by pi n square, this is minus 1 whole power n minus 1, cos n pi value. Therefore an equal to, what is the first one? 0 if n is an even. N is an even, right? When n is odd, minus 4 by pi n square, minus 1 minus 1 minus 2 if n is odd. If n is odd, this is over, okay? And it is defined for all n. There is no n equal to 0 is not included, okay, in an. It starts with 1. It starts with 1, okay? Now, what is another one? Bn. Similarly, what is Bn formula? Now, 1 by L, 0 to 2L, f of x into cos n, sorry, sin. Bn, there will be sin n pi x by L dx, okay? And L value 1, so this is 0 to 2, f of x into sin n pi x. Okay, just I will give hint and I will leave it to you. pi x into sine n pi x dx plus 1 to 2 pi into 2 minus x sine n pi x dx. Okay, and the result is bn value 0. Bn value 0. Okay, therefore you calculate that value. Fourier series is f of x equal to, what is a naught value? A naught value pi by 2 plus summation n is odd, and what is this value? Minus 4 by pi n square minus 4 by pi n square cos n pi x by L value 1 and bn 0. So this is pi by 2 minus 4 by pi summation cos n pi x by n square. N is odd, 1, 3, 5 and so on to infinity, right? This is f of x, and put x equal to 0. This is Fourier series. Put x equal to 0. This implies f of 0 equal to pi by 2 minus 4 by pi. After expansion you will get this, right? And from the given function, given what is f of 0? 0 is included in every function. Pi x value at x equal to 0, 0. Pi x value at x equal to 0, 0. Therefore, what is this? 0 equal to pi by 2 minus 4 by pi of this to entire summation 1 by 2n minus 1 whole square, and is 1 to infinity, right? This implies summation 1 by 2n minus 1 whole square is equal to this is here, this is here, so pi square by 8 is the answer. Okay, any doubts? Fastly, quick.